Hello students. In the last session, we discussed about the basics of serial communication. Now today in this session, we'll discuss about how to program the serial port of the 8051 microcontroller for serial data transmission and reception. To begin with, let us discuss about the format of the serial data transmission. Here, asynchronous data format. That means character by character, the data is transmitted as compared to block of data in the synchronous communication. Now in the asynchronous communication, on the screen, you see the frame for sending ASCII character A, whose hex code is 41H. You can see that in the binary over here. So how this 8-bit code that is transmitted over the TSD line. For that, you can see here, first the start bit that is sent, and then the LSB bit, that is the D0th bit, then the remaining bits one by one, then the D7th bit, the MSB bit of the data, and at the end you have to send a one stop bit, which is always high. So to send the 8 bits of the data, we need total 10 bits along with one start and stop bits, right? So that is how the asynchronous data format that is used for sending character by character data over the TSD line using the asynchronous data transfer. Now, whenever we need to have a communication between the personal computer and the COM port, the baud rate of the 8051 system must match with the baud rate of the PC COM port. We know there are two COM ports in the computers, COM0 and COM1. And here in the table, the various baud rates that are used, commonly used baud rates that are shown here, starting from 110 to 19200. So these are the commonly used baud rates. Now in the 8051 microcontroller, you know the TH1 register that can be loaded with the different values to obtain the variable baud rate. We know that the timer one that can be used in the mode 2 to set the baud rate. Now here, let us say whenever you want 960000 baud rate, -3 is the value that is to be loaded. So in hex it will be FD, right? Similarly, for 4800 -6, that is nothing but the FA. For 2400 -12, that means F4. And for 1200 baud rate, -24 means E8 is the value that is to be loaded in the TH1 register. Okay. Here, the clock frequency we are using is 11.0592 megahertz, right? So that is how you can achieve the variable baud rate in the 8051 using the TH1 8-bit register. Now, in the serial communication, the SFRs that are used, SBOF and SCON. Now here, SBOF register, which is not the bit addressable register, that is used for serial data transmission and as well as reception. The same physical register that is used for both. During transmission, the data has to be written in the SBOF register, and then the data will be transmitted over the TXD line. During reception, the data will be received through RXD line, and once the data will be available, it will be available in the SBOF register, which is then read from the SBOF to any other register or memory location. For this serial port, we know port 3, the two pins, P3.0 used as RXD, receive data, and P3.1 is used as a TSD for transmit data. So that is the full duplex serial port available in the 8051 microcontroller. Now after the SBUF, the next SFR that is used is nothing but the SCON register, which is the bit addressable register. You can see the format of the SCON register. Why it is called as the bit addressable? You can set or clear the individual bit of this SCON register. Now we know the MSB 2 bits SM0 and SM1, those are used for mode selection. SM2 is used for multiprocessing in mode 2 and 3. Then REN means receive enable bit. Then TB8, the 9th bit during transmission will go here, and the 9th programmable bit during reception will be received over RB8 at this bit position in the SCON, right? We can use that bit as a parity bit, right, in mode 2 and 3. Then TI and RI are nothing but the transmit interrupt and receive interrupt bits. We'll discuss in more detail about those later on. So that is the 8-bit format of the SCON register. Here, the explanation about the bits that is given. What we are interested is in SM0 and SM1 setting 0, 1. That means mode 1 we are going to use for serial data transmission, along with the 1 start and top bit, the 8-bit character that is transmitted, right? So that is the mode in which we are interested. Then SM2, as I told, that is used to enable the multiprocessing capability. Okay. Then REN is for receive enable bit, that should be 1 to allow the receiving the data or the RxD line. If it is low, the data will not be received. TI is nothing but the transmit interrupt flag, as I told, that is used during the transmission. Whenever the 8051 finishes the transfer of the 8-bit data, the TI flag that will be automatically set. However, during reception, whenever the data will be received serially over the TSD line, will be automatically set the RI flag. Next, in order to program the serial port, you have to initialize the different registers. You can see here the TMOD register that should be initialized with the value 20H, indicating the use of the timer 1 in the mode 2, that is the auto reload mode, to set the baud rate. Similarly, we need to initialize the TH1 register with the value as per the requirement of the baud rate. Then SCON, that is to be loaded with the value 50H to indicate that the serial port is to be used in the mode 1 with the 8 bits of the data along with the 1 start bit and 1 stop bit. Here you can see the run control bit of the timer 1, that is to be set to 1 to start the timer. Then TI bit is to be cleared using the CLR instruction once the transmission is finished, right? To receive the next, to transmit the next character. Okay. So character byte to be transferred serially is written into the SBUF register, and then the TI flag bit is monitored with the use of the instruction jump if not bit set TI to the specified address. So if the character has been transferred completely. To transfer the next byte, you have to go again, keep it in the loop. Now here, a small program that is written for transmitting a letter A serially at the baud rate of 4800. So as we discussed, these are the instructions used for initialization purpose. First, we initialize the TMOD register with value 20H, that indicates the timer 1 we are going to use, and in mode 2. What is mode 2? Auto reload. Then we loaded -6 value in the TH1 register, that indicates the 4800 is the baud rate. as it is mentioned here, right? Then SCON register, we are initialized with the PH value 50H. That is, we are going to use the mode 1, and in which we are going to transmit the 8-bit along with one start and one stop bit. Then we give the start command, run command to the timer using the set bit TR1. So timer 1 run control bit, that is set to start the timer. Now here you can see a character A that is written in the SBUF register, so that initiates the transmission. Then you have to wait for the flag, TI flag to set. So jump if not bit set TI, wait here only. Wait for the last bit. First the start bit, then LSB bit, then remaining data bits, then 8th bit, and then the MSB. That is nothing but the last is the stop bit. Then only the flag will be set. Once all the 10 bits that are transmitted. Now what you have to do, clear that interrupt flag and use YesJump instruction. That will go again here. So on the TSD line, this will continuously send the character A. So that is how, it's very simple how you can use the serial port for transmission of the data character by character. Now in this program, only single character we are continuously transmitting over the TSD line. Suppose you want to transmit some message. So let us go through the next example where you can see the message yes that is to be serially transmitted at the baud rate of 9600. Okay. So what you have to do again, initialize the registers, Tmod with 20H, TH1 with -3, SCON with 50H. Here you can see now 9600 is the baud rate, so value is -3. And here setting the run control bit to start the timer 1. And now the first character is taken, Y, that is written in the SBUF using the transmit routine. Again, wait for the flag bit to set, TI flag. When the TI flag is going to set, after finishing the transmission of the last bit, that means stop bit. Then clear that transmit interrupt flag bit and return for next character. Now, next is E character. So like that, E, then yes, all the characters one by one are transmitted over the TSD line. And here, yes jump to again kept it in the loop. So this yes message will be transmitted over TSD line. Here it is routine. Here it is written as a subroutine. Okay, so we are calling that subroutine in our main program using the absolute call instruction. Right. So that is how you can use the serial port, the TSD line, for transmitting the data one character at a time using the asynchronous communication. Now next is, here it is the, what is the importance of the TI flag that is shown. As I told you, when the stop bit is transferred, it is during the transfer of the stop bit that 8051 raises the TI flag, indicating that the last character was transmitted. Okay, so you have to ensure, because it may possible that there is a overlap. That means before transmitting the previous character, if we write the new character in the SBUF, then that may do the wrong data transmission or character may be lost, right? So if we write another byte into the SBUF before TI is raised, the untransmitted portion of the previous byte will be lost. So we have to take care, right? By checking the TI flag bit we know whether or not the 8051 is ready to transfer the another byte or not. Next, it must be noted that the TI flag bit is raised by the 8051 itself when it finishes the data transfer. So it is automatically set. We have to just wait till the flag bit is set. Once it is set, you have to, through program using the CLR instruction, clear that bit so that we have to go for next character, right? Then for serial data reception, similar is the procedure, only here we have to use the RI, receive interrupt flag bit, right? So while programming the 8051 for receiving the character byte serially, the TMOD register again initialized to 20H. TH1 is loaded with the set baud rate value. Then SCON register is to be initialized with the 50H to indicate that mode 1 that we are going to use. TR1 that is set to 1 to start the timer. And then using the reading the contents that are available in the yes buff, you have to check the RI flag. So RI is cleared by the CLRI instruction. The RI flag bit is monitored with the use of the instruction jump if not bit set RI to see if an entire character has been received or not. When RI is raised, SBUF has the byte and its contents are moved into the safe place. To receive the next character, again we have to repeat the loop. Here, a small program that is written for receiving character, one character at a time over the RxD line of the serial port. Baud rate used is 4800. So you can see TMOD register is initialized with the value 20H, that is timer 1, mode 2, auto reload mode. Then TH1 is loaded with -6 for 4800 baud rate. SCON with 50H, that is mode 1 of the serial port. Then set the run control bit using set bit instruction, and then jump if not bit RI. Wait for this flag bit to set, receive interrupt, which will be automatically set once the data byte has been received. So wait for the character to come in. Once the character will be available, the flag bit will be set. Then take that from the SBUF register where that is going to be available in SBUF. So take that into the accumulator, and through accumulator then it is sent to the port 1. Okay. So that is how the character is read from the SBUF register, and then clear the interrupt flag, receive interrupt, and yes, jump to here. That is waiting for the next character that is going to be received on the RxD line. So loop will be repeated. That is how one by one the characters are received over the RxD line, right? So very simple. That is how you can receive as many characters that you wish over the RxD line using the serial port of the 8051 microcontroller. Now the importance of the RI flag, as I told, it receives first the start bit, then it receives the data bits, last it will receive the stop bit. The bits are received one bit at a time. When receiving the stop bit, the 8051 will make the RI flag to 1, indicating that an entire character byte has been received, and that must be picked up before it gets overwritten by the another incoming character. So by checking the RI flag bit when it is raised, we know that the character has been received and that is available in the YesBuff register. A copy of YesBuff that can be then written in some same safe place. That's what we are doing, reading it in the accumulator and then sending it to the port, or we can save in the memory location. Okay. So after the YesBuff contents are copied, the RI flag must be cleared using the CLR RI instruction in order to allow the next received character byte to be placed in the YesBuff register. Failure to do this will cause loss of the received character. Okay. So we have to carefully clear that before going to read the next character on the RSD line through the YesBuff register. So that is how YesBuff that is used both for transmission as well as the reception. So by checking the RI flag bit, we know that the 8051 has received a character byte. Then you can double the baud rate. How? We know there is a SMOD bit in the peak-on register, which is the MSB bit. So by setting that SMOD bit, we can double the baud rate. Here you can see at the D7th bit position, there is a SMOD bit. There are two solutions. One is either to use the high frequency crystal, but you know the system crystal is fixed. So to change the bit in the peak-on register, peak-on is not the bit addressable register. So what we have to do? We have to, through accumulator, set that MSB bit. Let us see how that SMOD bit from the peak-on register that can be set using the instructions. Now here you can see, load the contents of peak-on into the accumulator and then set bit accumulator 0.7. So accumulator is a bit addressable. So the MSB bit you can set, that is the 7th bit, that is nothing but the SMOD bit. And now what you are doing, writing that accumulator contents at peak-on, in the peak-on register. So what will happen? SMOD will become 1 without changing any other bits. So that is how you can set the SMOD bit. Okay. Graphically it is shown here how we can double the baud rate using the SMOD bit. If the SMOD is 0, you can see here, and what is the frequency, and here using the SMOD equal to 1. So in this table, you will observe that how the baud rate gets doubled with SMOD bit equal to 1. Now here you can see, if the SMOD is 0, when we use the value -3 in the TH1, the baud rate is 9600. But if the SMOD is 1, then it will be 19200. If we use -6, then 4800 is the baud rate with SMOD equal to 0. 9600 is the baud rate with SMOD equal to 1. With -12 value, 2400 is the baud rate with SMOD equal to 0. Same with value -12, it will be 4800 with SMOD equal to 1. And here you can see with -24 value, so as compared to 1200 with SMOD equal to 1, you get the 2400 as the baud rate. So that is how you can double the baud rate using the SMOD bit of the peak-on register. So that is how you can program the serial port of the 8051 microcontroller with the help of SMOD and YesBuff registers. We can transmit characters over the TSD lines, as well as we can receive the characters over the RHD line. So that is how this full duplex serial port of the 8051 microcontroller can be used. So that's all for today's session. So what we discussed today is nothing but the serial port programming. For that, use of sbuff and scon. Then how the serial transmission and reception that can be done by programming the serial port or the PSD and RHD line. Also, we had seen how the variable baud rate that can be used with the value of TH1. And finally, we discussed about how to get the baud rate doubled using the SMOD bit of the keycon register. Thank you.